It's really interesting to reflect this World Quantum Day. We didn't come up here and talk to you about, these are our qubits. Here's how well they've worked and they've improved. We're not talking about these hardware details. We're talking about solutions. These are the things that actually matter to you all. And what I want to talk a little bit about is hearkening back to Nicolo's comment at the beginning. If you look at IonQ last World Quantum Day and you look at it today, we were a quantum computing company last World Quantum Day. We're now really a quantum platform company, and I would say more than that, a solutions company, because we're not focused on just a portfolio of technologies, but now that we can bring these and deliver these to customers, what solutions can we enable? And this isn't just a random grab bag of technologies. We actually were pulled into building these other technologies by our customers. So for example, we were pulled into quantum networking because we sold quantum computers to our partners at Air Force Research Lab in order to advance their quantum networking efforts. And we heard from Chad and Rick and from Nicolo earlier that the advances in algorithms, the advances in hardware for things like Shor's algorithm and breaking encryption have moved Q-Day to the left. And so for that reason, we're being pulled into investing more and more in quantum cybersecurity because we are the ones that are on the ground building this type of hardware, and we know best exactly what the implications are for your data. And so we have an obligation to help you secure that data against attacks. And so bringing these technologies together isn't about just a portfolio of things we can sell off a truck, about what solutions we can bring together. And I think Rick captured that really well by talking about PNT in space. And so now that we've built the platform, I want to talk about one more realization that we've had because customers have been coming to us. And as we've built these technologies, we don't often talk about what is underpinning them. What are the forces that are powering these technologies? But all of these technologies have a number of common threads, right? So they're all based on quantum mechanics, quantum physics. But what that means is that our core moat of 1,000 patents, our workforce of some of the most skilled quantum scientists and engineers, and the underlying technologies that enable quantum networking, sensing, and computing are actually really, really empowering for the entire quantum hardware ecosystem. And so it's really exciting for me as a technologist that's been building these quantum technologies a little bit behind the scenes, in a dark room in a lab somewhere for over a decade, to actually be coming out into the world and actually offering these technologies. And so I want to talk a little bit about our quantum core infrastructure, which is really the connective tissue, the stuff that's behind the scenes that's going to power every single quantum device, every single generation. And this is something we've already started doing naturally as we've put together the platform, right? So, IonQ already sells technologies that are at the heart of almost every quantum R&D lab. So our atomic clocks, for instance, Rick talked about these. These are some of the most precise commercial timekeeping devices. And not only do you need these for things like GPS, but already today in the lab, if you want to build a quantum computer, a quantum network, you need to synchronize time very precisely. That's the foundational element of being able to build a precise system. So these systems are deployed already in quantum research labs everywhere. One of the other things we do as part of our quantum networking business is detectors, the world's most precise detectors that can actually measure single photon devices. And before I joined IonQ, my research lab had dozens of these, so I was already buying them. Every single research lab, all the way to enterprise that's now building commercial technologies, is using this underpinning technology. And I'll talk more about the interconnect backbone that we're going to need to connect all of this together. But what I want to spend a moment on is something that gets me really excited, which is our planned acquisition of Skywater, which we announced a couple months ago. And so for me, of course, it's a little bit like being a kid in a candy shop, right? Skywater has amazing capabilities for advanced manufacturing, and so the ability to accelerate our own technology roadmaps we've talked about. But I'm not the only kid in the candy shop, right? Everyone in the ecosystem is excited about this because Skywater has so many advanced technologies that can accelerate the entire landscape of manufacturers of quantum computing, networking, and sensing devices. And so just to spend a moment, for those of you who don't know about Skywater, they really specialize and differentiate themselves from your standard foundry because they provide advanced technology services. So there isn't just a set of design files and you don't just send them an order and they just make you semiconductor wafers. No, they actually look at your problem and they look at the gaps in what exists today in semiconductor manufacturing, and they help to develop the new processes to fill those gaps and develop new capabilities. And that's what really distinguishes them, is these advanced technology services. And so for our ion traps, we actually really like them because they run on standard CMOS. But when we look at all of the other quantum technologies, the superconducting technologies, many of the technologies for advanced networking and interconnects, the technologies for other platforms like neutral atoms that require very complex laser systems, these need new capabilities. And these are exactly the things that Skywater specializes in. Superconducting routing for wiring up these chips, the world's lowest loss photonic circuits. So it's really, really exciting to be able to work very, very closely with Skywater, this acquisition that we hope will close in the coming months. And so when we look at all of this together, what does this mean? So we're now building not just quantum computers, not just a platform of solutions, but also the underlying technology that powers basically any device where you would want to do something with quantum, with any modality, be it neutral atoms, photons, superconductors. And that's really, really exciting because it means we can ensure that all solutions will really be powered by this technology we've invested in. And so today I'd like to share a little bit more about something that's very near and dear to my heart. It's really kind of our newest core technology capability. We've been talking about it since the inception, but we've been talking about it as a tool for how we're going to scale up our own trapped ion processors. And today I want to talk about how it's actually going to form the backbone of every single quantum data center that we're going to construct to build these systems at scale. And so this technology that we've shown in miniature in the past is powered by advanced integrated photonics that have been buried in the R&D lab for many, many years. But when you put them into a quantum network, can give you a big speed up, a 50x speed up in the rate of communication between devices. And this is exactly the kind of step change and speed up that's needed to make quantum data centers a reality where we can connect individual processors together. And what I'm excited to announce today is that we're building this system not just for our own trapped ion processors, but to be compatible with all different quantum hardware platforms. So be that trapped ions, neutral atoms, basically anything that has an optical interface, any quantum platform, we will be able to connect and provide the type of data center scale that's really required to deliver massive quantum advantage to customers. And so this is, again, it's been buried in an R&D lab for a while, so I'm very excited to share some timelines and some concrete specifications of what we are actually doing in this space. This isn't just a forward-looking vision that's going to be 5-10 years from now. This is something that we're actually executing on over the next 2.5 years. And it really starts in 3 phases. The first being to speed up these connections, the second to scale these connections up, and then finally to scale out these connections in being able to connect over even long distances. And this year we plan to release, hopefully in the coming months, our results showing that we can actually for the first time surpass the threshold. So we have the first devices where they can communicate at a rate that's sufficient for sustaining distributed computing. And in 27 and 28, we plan to add compatibility for different hardware platforms. So not just trapped ions, but also all of the other QPU providers. And so the reason that's important is because there are billions of dollars being invested by our governments, by our allies, by other companies to build lots of different types of quantum hardware. And all of them will ultimately need to scale up in this way. And we're investing to be 5, maybe even 10 years ahead in building this interconnect backbone. And so the timelines on here, I should point out, are really at least 5 years ahead of what any other industry player projects for being able to connect these types of computing systems. And so I'm very excited that we're taking this finally out of the R&D lab, and getting this to be validated. And Rick mentioned this validation. Today we announced a very exciting partnership that I think really shows validation for this vision. We were chosen by DARPA's HARC program. This is the Heterogeneous Architectures for Quantum. And basically DARPA's vision is exactly this. They know that for these technologies to be proliferated en masse, they have to enter hyperscale environments. They need to be in the data center. And IonQ is actually the only commercial company that was selected for a hardware award under HARC. So we are DARPA's chosen provider for this heterogeneous interconnect backbone. And it's not just DARPA, right? I think many folks see this, so we're very grateful also to our partners at University of Maryland, who have also really been visionary in the Mid-Atlantic Regional Quantum Internet. We're excited to announce an expansion of this engagement, and that expansion is really around building technologies for interconnect, for scaling. And so we're deploying one of these systems for the first time. It's the first commercial deployment of these systems into that hub. And so as you see us moving forward, we're not just providing individual quantum computing products or solutions, we're actually providing core technology that's underpinning the development of the next generation of quantum devices. And that's really what this quantum core infrastructure business is about. And so our goal ultimately here is to build the full connective tissue of the entire quantum ecosystem. So I think it's safe to say we are the leading quantum platform company, but we also have 800 advanced degrees at IonQ. We have over 1,000 patents in the area. There's an enormous amount of technology. It just breaks my heart that I can't bring all of you into the lab right now to show you all that technology, right? And our customers, other players in the hardware space, have come to us and asked for help with that technology. So with our quantum core business, we're bringing these horizontal components, some of the world's most advanced integrated photonics, our photonic interconnects, advanced semiconductor manufacturing for quantum, to market, and ultimately to ensure that all quantum solutions are powered by IonQ.